Hi, I'm Dave Potter with Dairy Connection. Today we're going to be reviewing pH and the importance of using pH in your cheese making or yogurt making, and also how do you measure pH and how do you care for the pH meter that you're going to be using. We'll be focusing on the Extech pH meter, the Extech 100. This is a pH meter that I use often in my cheese making classes, and it's also one that is provided by Dairy Connection. Some of the aspects that pH is important in is the quality of the milk. There is an initial pH of milk, usually between a 6.6 to a 6.7. It's important to know how fresh your milk is. Second is the coagulation of the milk. It's called the isoelectric point of the milk proteins. It coagulates at a certain pH. If you're able to measure that, that's when you make your chev or you're making yogurt. That's what causes the coagulation is the pH. And the third primary one is cheese making steps. Certain things happen. Trying to release calcium out of the cheese curd helps for mozzarella stretching. It helps for texture in cheese. And so there's important ranges that pH plays that you should measure if you can, especially if you want to improve your product. So first I'd like to go through the parts of the Extech 100 pH meter. When you first pull it out of the box, it's important to know what each part or the description of the items are. So this is a digital display, and so the part right here is called the body of the pH electrode. This is where you're going to have the actual reading of the pH. The second most critical point on here is going to be the actual electrode tip. And this is the part right here. The measurement takes place at the very bottom. And this is the critical point of maintenance of your pH electrode, of keeping it clear of calcium and protein and fat that are inherent with dairy products. If you're going to have a problem with the pH meter, this is the probe that's going to be replaceable, and it basically will just screw off, and you can replace this and still maintain the body of the pH electrode. And it just simply is an electronic part that comes apart like this, and we replace that. The life expectancy of this electrode is usually about 1 to 2 years. The other area that you may have is the batteries. The batteries are under this cap. You simply unscrew the cap, and there are 4 batteries in there that can be replaced. So that's the basic concept of the pH electrode. It should be kept wet at all times. When the electrode is delivered, you will see this cap that comes over it. I have another one over here that shows a sponge that is in the bottom of it, and then there's going to be like a pH 4 buffer or liquid to keep the electrode tip moist at all times. If it dries out, you'll have a problem with that, and we'll get into that when we start troubleshooting problems with the pH electrode. But always store it in this liquid, and this is the unit itself. So we're going to first talk about the use of the pH electrode, and the first step that you're going to be doing is calibrating it. It's important to have a calibrated meter so that you're reading an accurate pH. And to do that calibration, we have to tell the electrode that we have a standardized set of pH values, and the 2 calibration buffers that we use are a pH 7 buffer, which is neutral, and a pH 4. Those 2 pHs pretty much cover the range of all milk, cheese, fermented products that you're going to be making with this. And so we wanted to know that when it's reading a 7 and it's reading a 4, that anything in between is going to be accurate. So the first step in calibrating your pH electrode is to make sure the electrode is clean. And I rinse that off in distilled water, and I blot it dry. I always recommend distilled water because tap water can leave a calcium deposit on the end of the pH electrode where the sensing takes place, and that can block that measurement. To calibrate, we want to go with the first neutral pH, which is a 7. And on this electrode, there is a middle button called Calibrate, C-A-L. You stick it in the 7, and you can see that it is going through its process. And when it reaches an endpoint, it will say End. That's when you know that the calibration process has been reached for the 7 buffer, and you can then remove it. And there's the end. Again, we take it out, and before you put it into the other buffer, you want to rinse it, blot it dry, place it in the 4 buffer, and again, repeat the step of pressing in the calibration. It is now going to calibrate down to the 4 pH, so that we'll end up with an accurate measurement from 4 to 7. And again, it goes through this process until it reaches an equilibrium, and then the end will come up, and then it goes back and standardizes. Once that is reached, you can rinse it off. And at that point, you are able to ready to start measuring. My recommendation is to calibrate once a day. If you're making cheese all day long, I would calibrate in the morning, maybe in the afternoon as well, or if you're only making cheese once a week, make sure you calibrate before you start the cheese making process. At this point, you can measure the pH of your sample or whatever it is that you're going to be checking, or simply put the cap back on and it's ready for use when you start your cheese making process. So I want to review some of the common errors that people have with the pH meters that we hear often. And a lot of it is just understanding what it is you're doing. The first one is proper calibration. I went through the techniques of how to calibrate. One of the things I want to mention is the pH buffer solution, is that it should be fresh. It does have an expiration date, so when you purchase these standardized solutions, make sure you monitor when that pH buffer solution will expire. It does go weak, and if it goes weak, then your calibration will not be accurate. It's also important to not dip your electrode into the bottle, but pour some of the solution into another container, and don't pour the solution back into the bottle. That will cause a contamination of the pH buffer, and your calibrations will be incorrect. I would also recommend keeping them covered if you're going to use the same calibration throughout the day to keep evaporation from occurring or from other contamination getting into the product. If you clean your electrode properly, you should not be contaminating with cheese or yogurt or other parts. Some of the other errors that we see is battery could be low. If you don't calibrate the electrode, it will give you a measurement on here, that readout that says time to calibrate. It'll say CAL. So that's why I recommend calibrating it each time before you start your process. Also, the pH electrode, after a certain amount of time, it does wear out, and it's built on electrical charges, and you can have an error code that will show up, and it may say a -1. It's usually time to replace that electrode. The electrode, you should expect 1 to 2 year life out of the electrode when you purchase this. And again, you can remove the electrode and replace it with a new one without having to replace the entire thing. When you run into some errors, you can get static charges build up. And the recommendation is to do a hard reset. Part of that hard reset process is to take off the cap, remove the batteries, and hold down the top two buttons, the bottom and the top button, at the same time, and that will release any static charge that is built up in your electrode. And then go ahead and reinsert the batteries, and it should function normally after that. Other things that can cause issues with the electrode is if it were to dry out. Our recommendation is to store it in a cap. There's a sponge in the cap with liquid. Always keep the electrode tip wet. If it does dry out, it may take up to 8 hours of soaking into a 4 buffer to rehydrate and reactivate the electrode. So that's one thing to check on when you get a new electrode. Is it wet or is it dry? And my recommendation is to soak it for at least 4 to 8 hours before using it the first time. Other things that can cause a problem with it if it freezes. If you were to leave it in your environment, in your barn, in your house, in an area, there is a liquid in there. That freezing of that liquid could cause the electrode to crack and give you an error reading on the pH electrode. So a lot of it is common sense, just using normal care. Also, I talked about blotting. You don't want to wipe it. You don't want to use a bristle brush on it to clean any material off, because it can cause a scratch on the end here where the electrode reading takes place, and you'll get an error at that point. Otherwise, it's pretty simple from the application and just using a lot of common sense on how to use it. So now we're going to go through the actual application and use of the pH meter. I have 5 samples in front of me, ranging from fresh milk down to Chev, cultured yogurt, and orange juice. So the first one we're going to do is make sure you want to rinse your pH electrode again. You don't know when the last time it was used. You don't know what may be on it, but you want to make sure it's clear and blot it dry. And always bring your sample to the pH meter. Don't stick your pH meter in your cheese vat, in your yogurt tank. You want to bring the sample in a small container to this. And our expectation now, so I've read this, we are at a 6.69. So again, I mentioned typical pH range of fresh milk is 6.6 to 6.7. So I'll rinse that out. Always rinse out between samples. Blot it dry. And then the next one here, this is 2% milk. So the main difference is going to be that it has some fat. Sometimes the processing of it can cause an issue. Sometimes the cream can raise the pH. We have an initial pH of our 2% milk 6.73. Again, these are different batches or different lots of milk, but it's still within the range of what you would expect fresh milk to be at. Again, I'm going to rinse this dry. So those are our initial pHs for starting the product. Now we have a solid or a semi-solid with the Chev. This is a flat bottom probe. We can simply push the electrode into the cheese, and we're going to measure this. And this is a fermented milk, so this is a goat milk. It's reached an endpoint, and we're getting a reading of 4.2. So you can see much more acidic than what the milk is, and that's pretty common range for what a Chev may be. It may be up as high as a 4.8, 4.6, but typically it's going to be somewhere around that range. And again, you want to blot it dry. Make sure you have no cheese on it. The next product we're going to be testing is yogurt. So this is a cup set yogurt, and this is, depending on the culture used, typical ranges of yogurt are going to be between 4.1 to 4.5. We have a reading of 4.32. One of the things you'll notice on the pH measurements is it usually takes about maybe 10 seconds, and you should have a stabilized pH reading. If your pH is drifting all over the place after that point, there may be an issue with your electrode. And again, we'll rinse it off and we'll blot it dry. So here is our unknown sample, which is our orange juice. And again, we'll put this in here. And I would expect the orange juice, because of the citric acid, it's usually a lower pH. And we're getting, with this, I'm getting a 3.87 pH. So by far of these five, the pH of the orange juice is much lower and much more acidic. One thing about the orange juice now, we calibrated to a 4 and a 7 pH. As you get outside of that calibration range, you're now introducing maybe an error in your readings the farther away you go from 4 and the farther away you go from a 7 pH. So those are examples of the different products that you can measure pH on. Primarily with the dairy products, you're going to start with fresh milk somewhere around a 6.6 to 6.7. As it goes through the fermentation of making a Chev or making a yogurt, that pH will continue to drop down, and we will end up with a measurement of about a 4.0 on the end products. So that was an overview of the use and application of the pH meter. For more information on what pH is and how to use it in your process, please check out our blog. One of our technical specialists, Bill, has written an excellent article on how to measure pH and what pH is, to more explain the use of the pH meter in your process. So that should be it for now, and happy cheese making.